Hey guys, it's Booth Dog again. Hope you're all doing well. I know this is definitely going to be an adjustment for everybody, so just know that I am here if you need absolutely anything. Mr. Boothman's going to deliver some lessons very shortly. Why don't we bring him on camera now? All right, Mr. Boothman here. Let's get started. All right, day 2, section 8.3, we are talking about volumes of different solids and using our tools of calculus to help us compute those volumes. Before we get started, just some brief announcements for the day. Please note that much like yesterday, you're going to have another Google Form exit ticket today. Just like yesterday, you'll be asked to submit a question you have about any of the problems we worked through today. Please, if you have no questions, then I'm asking you to come up with a question, something you think someone might be confused about. Even if you know the answer, I want to see that you're actually engaging with what we're studying. This will count as your attendance for the day, okay? I said yesterday that we were skipping over this particular question, okay? So to jump back in, we have two semicircles as the base of some solid, okay? From -1 to 1, this is our x and our y axes. The top part of this semicircle was given by this equation, the bottom part by the negative square root. Okay, so this actual equation is x squared plus y squared. When we solve that for y, we get these two solutions. So this is the base of some solid. Yesterday we looked at what happens when we take semicircles set along this circle. We looked at what happens when we take an entire circle, cross-section going through. We also looked at taking a square with its base on here. And that was a question I asked you to work through yourself. Okay, hopefully you engaged with that. Now, today I want to go back to part C, this particular visualization can be tricky. So let's take a look. The cross sections are squares, okay, square again, with diagonals in the xy plane. So the base of the square isn't sitting on the xy plane, it's diagonal. In other words, the middle of the square is sitting in the xy plane. So kind of like yesterday's circular cross sections, take this square, imagine that it's going through the board. So half of the square is sitting on the other side of this board. The other top half is sticking out from the top. And so what we would see here is this. How do we find the volume of this three-dimensional shape? Well, we know that our volume is given by the integral from -1 to 1 of a of x dx. We need to find a formula for the area of this cross section. We need a formula for the area of this square. We're told that the length of a square is diagonal, so I'm going to call this the length of a square is diagonal, is the square root of 2 times the length of one of its sides. Okay, and that's coming from geometry. That's coming from our special right triangles. This is a 45, 45, 90 triangle. How can we take this and use it to find the area of this entire square? What is the area of a square? Side squared. What do we know? Okay, again, our goal is to take this and write a formula that is in terms of x for the area of this square. Well, we know that this diagonal right here, diagonal, is going to be, if I had drawn this actually correctly, this is equivalent to this distance. And what is this distance right here? For this given x value, It's this given y value. So this distance right here is the square root of 1 minus x squared. That means this distance here, again, it's a symmetric circle, is also the square root of 1 minus x squared. So what is this entire distance? 2 times the square root of 1 minus x squared. This is, in fact, hopefully you looked at this yesterday, what the side length is for a square with its base on the xy plane. Okay, so you would have taken this and squared it to find the area of your cross section. Today, however, this is the length of the diagonal of one of these squares. And the diagonal equals the square root of 2 times the side length. So how do we find a side length? Divide both sides by the square root of 2. And how are we going to find the area of this square? Square that. 2 squared is 4 times 1 minus x squared all over square root of 2 squared is 2. And here's the area of a cross section in terms of x. So our volume is the integral from -1 to 1, 2 times 1 minus x squared dx. This, again, like yesterday, can be very difficult to visualize. I'm doing my best with this flat board and this piece of paper, but I get that you might need to see this a couple of times. So if you need to go back and rewatch this whole part, once we get the length of that diagonal, then we're using the relationship that they gave us, which is always true for a square, any square, to solve for our side length, to square it, to get our answer. Okay. Feel free to ask me any questions you may have during Q&A time today. I would like you to turn your attention to the rest of the second column, the right column on that first page. Okay. I'll go through part B, and then I'll ask you to finish C and D yourself. So by the end of today, you should be done with the first page of your 8.3 mastery sheet. Starting tomorrow, I'm going to move on to something very related, but a little different. But really, being able to visualize and conceptualize what I'm talking about here with our volume will be very important going forward through the rest of this section. All right, so we have, pulling up our mastery sheet here. Instead of a circle being the base of this solid, we're told that the solid lies between planes perpendicular to the x-axis at x equals 0 and x equals 4. And the cross sections perpendicular to the x-axis between these planes run from y equals negative square root of x to y equals positive square root of x. Much like our circle, this is actually the shape. X equals y squared, but if we solve this for y, we get plus or minus square root, and so it splits into two separate functions. Okay, most square roots in circles work this way. Now for part B, we're told that our cross sections are squares with bases in the xy plane. Okay, so this is basically like yesterday, the one that I asked you to try yourself. Each base is sitting on this plane. Each cross section is a square. And of course, as we get further out, the squares get much larger to keep its base touching our functions. Volume is the integral from 0 to 4 of a of x dx. So it is up to us to find a formula for the area of the cross section, for the area of one of these squares in terms of x. We know that the area of a square is side length squared. what is the side length of a square? Well, if I'm setting it right there, then here is its side length. We know that this distance right here is the square root of x. This distance right here is also going to be the square root of x, right? This is symmetric. I know this is negative, but we're talking about distance here, so it's always positive. That means this entire distance, this entire side length, is 2 times the square root of x. So our area is 2 times the square root of x squared. 2 squared is 4. Square root of x squared is x. And so our volume is going to be the integral, the infinite sum from 0 to 4 of 4x dx. That's all there is to it. Now C and D get a little trickier. Again, part C, much like the example we started today with, is looking at squares with diagonals sitting on this plane. Okay, so it's going to work a lot like the first example we did today. And part D is pretty interesting. This time the cross sections are equilateral triangles with bases in the XY plane. So imagine a triangle coming out with its base sitting right there. Okay. So think very carefully about it. That one's definitely a challenge one, so don't freak out if you can't get it. As I said before, your homework today is going to be another Google form exit ticket, just checking in, asking me any questions you have about the examples I just went through. I'd like you to finish the first page of this mastery sheet. Okay. Tomorrow we'll move on to something a little different. Also remember that you have an AP Classroom assignment that is due tomorrow by the end of the day. I will very likely extend it, but please, at some point you need to make sure that you're doing it. Starting tomorrow, I will put in those grades. When I say extended, I mean if you don't finish it by tomorrow, I'll still give you the grade if you finish it in the coming days. Okay, but that will be a grade. It will be a 0 until you get it done. So make sure you're doing that. Send me any questions you have. Otherwise, see you tomorrow. All right, well, that's it for today. Hopefully, you're starting to get into some sort of a routine. Again, let me know if you have any questions or concerns. Email me, Google Meet during our Q&A time. Anything you need, I'm here for you. All right, have a good one. And make sure to hit that like and subscribe button on your way out.